In this video, we are going to talk about logarithmic differentiation. Now, let's assume that we have a function f of x which is equal to ln of g of x. How do we find f prime of x? The rule says that f prime of x is equal to, you differentiate g of x, so that becomes g prime of x, then divided by g of x. So this is the general rule for making logarithmic differentiation. So for example, let's assume that f of x is equal to ln x. What is f prime of x? So now, in this case, we see that g of x is equal to x. So g prime of x is equal to, if you differentiate x, you will get 1. So if we put it into this equation, then f prime of x is equal to g prime of x, and g prime of x is 1, divided by g of x, and g of x is x. So f prime of x of ln x is 1 over x. Now, let's assume that f of x is equal to ln into bracket x exponent 4. What is f prime of x? So in this case, you see that g of x is equal to x exponent 4. So g prime of x is equal to 4x cubed. Now, having found g prime of x, then let's put it in the formula. So f prime of x is equal to g prime of x, which is 4x cubed, divided by g of x, and g of x is x exponent 4. So f prime of x is equal to 4x exponent 3 minus 4, and f prime of x is equal to 4x exponent minus 1. So f prime of x is equal to 4 over x. So we could also use another method. The other method we can do is to say f of x is equal to, so now using the properties of logarithms, ln x exponent 4 can be written as 4 ln x. So f prime of x is equal to 4 times. Now if you differentiate ln x, you differentiate x, which is 1, divided by x. So f prime of x is equal to 4 over x. Now let's assume that we have f of x equals sieve root of x. Then what is f prime of x? So now we can write f of x as equal to ln into bracket x exponent, sieve root of x is the same as 1 over 6. So now, how do we go about this? You see that using the properties of logarithms, then f of x is equal to 1 over 6 ln x. Now, we already know the differentiation of ln x. If you differentiate ln x, you will get 1 over x. So f prime of x is equal to 1 over 6 times the differential of ln x is 1 over x, so times 1 over x. And therefore, f prime of x is equal to 1 over 6 times. If f of x is equal to, into bracket, ln x exponent 3, then what is f prime of x? So what we need to do in this case is to take the ln of both sides. So this becomes ln f of x equals ln into bracket ln x all exponent 3. So this then becomes ln f of x equals 3. We are bringing this down, so 3 ln into bracket ln x. So now remember that we said that if you differentiate ln of a function, it is f prime of x divided by f of x. Then this is equal to 3 times. Now we want to differentiate ln of ln x. Now let's do something here. It means that g of x is equal to ln x. So g prime of x is equal to 1 over x. So now, in this case, g of x is ln x. And if you differentiate ln x, you will get 1 over x. Now, so this becomes 3 times. If you differentiate ln of a function, you differentiate what is inside. And if you differentiate ln x, you will get 1 over x divided by ln x. So f prime of x divided by f of x is equal to 3 over x ln x. So therefore, f prime of x is equal to f of x times 3 over x ln x. Now, what is f of x? F of x is all of this. And therefore, f prime of x is equal to ln x exponent 3 times 3 over x ln x. So this then becomes f prime of x equals 3 ln x all exponent 3 divided by x ln x. Now, continuing further. So f prime of x is equal to, you see there's ln x here, there's ln x here. So this becomes 3 ln x exponent 2 divided by x. Now, what if f of x is equal to log into bracket g of x base a? You see that the first one was a natural log, and then this one is the normal log. So now the rule says that f prime of x is equal to, you differentiate g of x, you get g prime of x divided by g of x, but this time you compensate the log with ln a. So now let's assume f of x is equal to log x squared base 6. What is f prime of x? So in this case, you see that g of x is equal to x squared. G prime of x is equal to 2x. So f prime of x is equal to g prime of x, which is 2x, divided by g of x, x squared. Then ln the base a in this case is 6, so ln 6. So f prime of x is equal to, one of this x will cancel this out, so it becomes 2 divided by x ln 6. So this is the final answer. Now, what if f of x is equal to log root x cubed base 2? What is f prime of x? So now we can write f of x as log, now root x cubed is the same as x exponent 3 over 2 base 2. So using the properties of logarithms, then we can say that f of x is equal to 3 over 2 log x base 2. So in this case, g of x is equal to x, g prime of x is equal to 1. So f prime of x is equal to 3 over 2 times, now g prime of x, which is 1, divided by g of x, which is x, then times ln 2. So f prime of x is equal to 3 over 2x ln 2. What if f of x is equal to sine x log tan x base 7? What is f prime of x? Now, what do? We need to use the quotient rule. Remember that if f of x is equal to h of x times g of x, then f prime of x is equal to h prime of x times g of x, then plus h of x times g prime of x. So in other words, you maintain this, differentiate this, and add it to, you maintain this and you differentiate the other function. So in this case, f prime of x is equal to, differentiate sine x, you will get cos x. Then you multiply it by g of x, which is in this case is log tan x base 7. Then you add it to h of x, so that means you keep sine x, so we are keeping sine x. Then you multiply by g prime of x, so we need to differentiate log tan x. Now in this case we need to differentiate tan x. If you differentiate tan x, you will get sec squared x. Then you divide it by g of x in this case, which is tan x. Then you compensate it with the natural log of the base, which is 7. So this is equal to cos x log tan x base 7. Then plus comes now sine x times 1 over sine squared x divided by tan x ln 7. So this is equal to cos x log tan x base 7 plus, now one of this will cancel out, it becomes 1 over sine x tan x ln 7. So this is the final answer. Differentiate with respect to x, y equals into brackets x over 1 minus x exponent x. So we have y equals into brackets x over 1 minus x exponent x. So we can take the natural log of both sides. So ln y equals ln into brackets x over 1 minus x exponent x. So in the second step, ln y equals x ln into bracket x over 1 minus x. Now let's apply the properties of logarithms in this case. So this becomes x then times, now since they are dividing, this becomes ln x minus ln into bracket 1 minus x. So now ln y, let's differentiate now. So if you differentiate ln y, it becomes y prime over y equals, now this is, we need to use the product rule in this case because this is two functions that are multiplying. So you differentiate x. If you differentiate x, you get ln x minus ln into bracket 1 minus x. Then you add it to, you keep x and multiply by, if you differentiate ln x, you get 1 over x. If you differentiate minus ln 1 minus x, if you differentiate 1 minus x, you get minus 1. Then minus 1 times minus 1 becomes plus 1. So this becomes plus 1 divided by 1 minus x. So continuing from where we left off. What we need to do in this case is we can write this 2 as a single log, but we can find the LCM of this. So this becomes x times, now this is x times 1 minus x, so that x times 1 minus x divided by x, this becomes 1 minus x, then plus x times all of this multiplied by x, then y prime over y is equal to, let's write this as a single log. This becomes, sorry, let me write it here, y prime over y is equal to, so this becomes ln into bracket x over 1 minus x, then plus. So continuing further, y prime divided by y is equal to ln to bracket x over 1 minus x, then plus x times, this becomes 1 minus x plus x is 1 divided by x times 1 minus x. Now you can see that this x and this x can cancel out. So y prime divided by y is equal to ln to bracket x over 1 minus x, then plus 1 divided by 1 minus x. So y prime is equal to, remember that y in the question was given us into brackets x divided by 1 minus x exponent x, then all of that times ln into bracket x over 1 minus x, then plus 1 divided by 1 minus x. So this is the final answer. Now, if y is equal to the square root of 1 minus 3x divided by into bracket 1 minus x exponent 3, then what is y prime? So what we can do is that we can find the natural log of y equals natural log of into bracket square root of 1 minus 3x divided by into bracket 1 minus x exponent 3. So let's apply the principles of logarithms here. So this becomes ln into bracket 1 minus 3x exponent 1 over 2, then minus ln into bracket 1 minus x exponent 3. So now this becomes ln y equals 1 over 2 ln into bracket 1 minus 3x, then minus 3 ln 1 minus x. So if you differentiate this, it becomes y prime over y equals. Now, if you differentiate this, it becomes 1 over 3 times. You differentiate what is inside. 1 minus, if you differentiate 1 minus 3x, you get minus 3 divided by. Then you differentiate the whole thing, which becomes 1 minus 3x. So this is a times. There's a times here. Times. Then minus 3. If you differentiate 1 minus x, you will get minus x, so times, minus 1, so times minus 1 divided by 1 minus. So let's continue from this side. So in continuing from this side, this becomes y prime over y equals. Now, if you multiply 1 over 2 by minus 3 over 1 minus 3, it becomes minus 3 over 2 times 1 minus 3x. Then this side becomes plus 3 over 1 minus x. So we can find the LCM in this case, and the LCM is 2 times 1 minus 3x, then times 1 minus x. So this part will divide this, so here becomes minus 3 times 1 minus x plus 3 times 2 times 1 minus 3x. That is for this part of the term. So this is equal to y prime over y. So y prime over y is equal to, let's expand this. So minus 3 times 1 is minus 3. Minus 3 times minus x is plus 3x. Then 3 times 2 is 6. 6 times 1 is 6, so plus 6. Then 6 times minus 3x becomes minus 18x divided by 2 times 1 minus 3x times 1 minus x. So y prime over y is equal to minus 3 plus 6 is 3. Then minus 3x minus 18x is minus 15x divided by 2 times 1 minus 3x times 1 minus x. So now we can put in the y. So y prime is equal to y. Now we know that y is into bracket 1 minus 3x exponent 1 over 2 divided by 1 minus x exponent 3 times, now this 3 over 2, let me factorize 3 over 2 out of this. So if we factorize 3 over 2 from here, so we are multiplying by a constant 3 over 2, then times. So if we factorize 3 out of here, it becomes 1 minus 5x divided by 1 minus 3x, then times 1 minus x. So y prime is equal to, now you can see that there is 1 minus x here, 1 minus x here, so that can also multiply. Now you can see here 1 minus 3x, 1 minus 3x. So now this becomes 1 over 2 minus 1, which becomes minus 1 over 2. So at the end of the day, so the final answer y is equal to 3 over 2, which is this constant, times 1 minus 5x divided by, now this one is exponent 3 times 1 will make it exponent 4. So that will be 1 minus x exponent 4. Then times, here is 1 minus 3x exponent 1 over 2. Remember that 1 over 2 minus 1 is minus 1 over 2, which becomes 1 minus 3x. 1 divided by 1 minus 3x over 1 over 2. So bracket close. So this is the final answer. So let's differentiate this function. Y equals into bracket x minus 1 exponent 2 times into bracket x minus 2 exponent 3 times into bracket x minus 3 exponent 6. So the way to go about this is to take the natural log of both sides. X minus 1 exponent 2 times x minus 2 exponent 3 and times x minus 3 exponent 6. So y prime over y is equal to, now applying the rules of natural log, or better still, we can say then y is equal to, let's apply the rules of logarithms here. So this becomes 2 ln to bracket x minus 1 times, plus 3 ln to bracket x minus 2, then plus 6 ln into bracket x minus 3. So y prime over y is equal to 2 times, if we differentiate this, it becomes 1 divided by x minus 1. Then plus, if you differentiate all of this, it becomes 3 times. If you differentiate x minus 2, it becomes 1 divided by x minus 2. Then plus, if you differentiate it becomes 6 times 1 times x minus 3. So y prime over y is equal to 2 over x minus 1 plus 3 over x minus 2 plus 6 over x minus 3. So now y prime is equal to, what is y? Y is all of this, which is, so let me use a bracket here. Bracket x minus 1 squared times x minus 2 cubed times x minus 3 exponent 6. All of this multiplied by 2 over x minus 1, then plus 3 over x minus 2, then plus 6 over x minus 3. So this is the final answer. So we have this question here, which is if y is equal to x exponent sine x, then what is y prime? Y prime is equal to what? So let's take log of both sides. So ln y is equal to sine x ln x. So now this differentiation, you need to use the product rule. So y prime over y is equal to, maintain ln x and you differentiate sine x. If you differentiate sine x, you get cos x. So cos x ln x, then plus maintain sine x, then differentiate ln x. If you differentiate ln x, is 1 over x. So y prime over y is equal to cos x ln x plus sine x over x. So now y prime is equal to, now y is x exponent sine x times cos x ln x plus sine x over x. So this is the final answer. Now there is this question that says that if y is equal to ln x exponent x, then let's find y prime. So now ln y is equal to ln into bracket ln x exponent x. So ln y is equal to x ln x. So this is product of two functions. Y prime over y is equal to differentiate x and maintain this, that is ln x. Then you maintain x, so plus x. Then you differentiate all of this. If you differentiate this, it is 1 over x, then divided by ln x. So y prime over y is equal to ln x, then plus x times 1 over x is 1 divided by ln x. So y prime over y is equal to ln x ln x plus 1 divided by ln x. So y prime in this case is equal to, now remember y is ln x exponent x, then times ln x ln x, then plus 1 divided by ln x. So y prime is equal to, you see this is ln x exponent x divided by ln x, so it becomes into bracket ln x exponent x minus 1, then times ln x ln x plus 1. If f of x is equal to sine x cos x plus cos x sine x, then find f prime of x. So now you see that f prime of x is equal to d dx of sine x exponent cos x, then plus cos x exponent sine x. Now, by using the principle of differentiation, f prime of x is equal to, in this case we can break this differential into 2, so it becomes d dx of sine x exponent cos x, then plus cos x exponent sine x. Now I want to explain, plus, so exponent cos x plus d dx of cos x exponent sine x. So now I want to explain this, use this to explain a principle. So this means that if we let sine x exponent cos x be equal to f of x, h of x, so f prime of x is equal to d dx of, now we want to let sine x exponent cos x to be equal to h of x, so this is h of x, then plus d dx of, we want cos x exponent sine x to be equal to gen of x. So in this case, f prime of x is equal to, if you differentiate h of x, you get h prime of x, plus if you differentiate gen of x, you get gen prime of x. So f prime of x in this case is equal to h prime of x plus gen prime of x. So now remember that we said h of x is equal to sine x exponent cos x. So in this case, let's find natural log of h of x. This is equal to cos x, then ln sine x. So now in order to differentiate this becomes h prime of x over h of x, then plus, now to differentiate this, differentiate cos x, you get minus sine x, then ln sine x, then plus, maintain cos x, differentiate ln sine x. If you differentiate sine x is cos x, then divided by sine x. So continuing, then h prime of x over h of x is equal to, now this is minus sine x ln sine x, then cos x becomes plus cos squared x divided by sine x. So simplifying further, h prime of x over h of x is equal to minus sine squared x ln sine x plus cos squared x, divide all of that divided by sine x. So if we then put in sine x cos x, then h prime of x is equal to h of x. H of x is sine x, all exponents cos x, then times into bracket cos squared x, then minus sine squared x ln into bracket sine x, all of that divided by sine x, bracket close. So h prime of x is equal to, now that is divided by sine x, this is sine x, so it becomes sine x exponent cos x minus 1, all of that times cos squared x minus sine squared x ln into bracket sine x, bracket close. So we've been able to find h prime of x. So it's like we're finding g prime of x. But remember that we said g of x is equal to cos x, all exponents sine x. So ln g of x is equal to sine x ln cos x. So now, in differentiating this, then g prime of x over g of x is equal to, now maintain differentiate sine x, which is cos x, then you bring ln cos x, then you add it to maintain sine x, differentiate ln cos x. If you differentiate cos x, is times minus sine x divided by cos x. So g prime of x over g of x is equal to cos x ln cos x, then minus sine squared x divided by cos x. So g prime of x over g of x is equal to, now what do we need to write this as a single, so it becomes cos squared x ln cos x minus sine squared x, all of that divided by cos x. We established that g prime of x over g of x is equal to cos squared x ln cos x minus sine squared x over cos x. So g prime of x is equal to g of x, and g of x in this case is into bracket cos x exponent sine x, then all of this times cos squared x ln cos x minus sine squared x, all of this divided by cos x. So continuing from here, then g prime of x is equal to, you see there's cos x here, so it becomes cos x, all exponent sine x minus 1, all of that times cos squared x ln into bracket cos x minus sine squared x, bracket close. Now remember that we said f prime of x is equal to h prime of x plus g prime of x. So now f prime of x is equal to, what is h of x? H of x we got as into bracket sine x exponent cos x minus 1 times into bracket cos squared x minus sine squared x ln into bracket sine x, bracket close, then plus g prime of x, and g prime of x is cos x into bracket exponent sine x minus 1 times cos squared x ln into bracket cos x minus sine squared x. So this is the final answer.